Good afternoon. Today we will be tackling the last lecture about the concepts of programming languages, and the main objective of this lecture is just to take a look at the previous paradigms and see which language is the most appropriate language to solve specific problems. Okay, now once you want to learn programming languages in general, you will have a variety of programming languages, and the question is, I would love actually to choose the best one to solve my problem. Okay, now look, we start actually to look at Python, and Python nowadays is considered to be one of the most commonly used programming languages. It's an easy one. Then the second language that we took a look at was Java. Java is considered also to be one of the most common and in-demand programming languages in the industry. There are a lot of applications that can be implemented actually using Java, and the topic of today is to know when to use what. Okay, last but not least, during actually the course we looked at different programming languages and different paradigms, like Haskell. Haskell is a functional programming language. We took a look at Prolog, and Prolog is a logic programming language. Now let's start from scratch. What I want actually to do is I want actually to recall, let's say, problems, one problem that we started to discuss the first lecture. Okay, the problem is an easy one. I have a list. The list consists of 1, 2, 3, 4, 5. Okay, and what I want actually to do is I want to filter out all odd numbers out and keep only the even numbers. That means if I were run, let's say, my problem, then actually 2, 4 will be the result of my algorithm. Okay, now let's start. We will start actually with the first programming language that we learned during the first semester. It's a simple one. Okay, thus I will take this one as a list. Okay, I will call it list equal to 1, 2, 3, 4. Okay, and then what I will do is I will use a for loop. Okay, thus the for, I will take for e in list. Okay, and what I will do is I will just check the following. If e modulus 2 is equal to 0, then what I need actually to do is I want actually to keep it. That means I will have a result list. Okay, I will take it and I will concatenate actually to it the e in this case, and last but not least I will print the result. Okay, thus before actually running it, what I will do is I will start with the result list, which is equal to 91. Okay, now once I will compile it, then actually what you will get here is you will get actually 2, 4. I'm using actually a for loop, okay, which is available in Python. And once we take a look at, let's say, this style of programming, it's an imperative actually programming style. Okay, so we will start, let's say, to recall the different paradigms one by one. Okay, now what does it mean that actually this paradigm is an imperative one? You are having actually a command. Okay, you are having a set of commands that you are applying till the result will be computed. That means I will start just by assigning the result to be equal to an empty list, and then what I will do is I will take all elements one by one actually from the list, and I check if this element is an even number, thus I'm using e modulus 2 equal to 0, then I will keep it actually in the result. And if it is not the case, then I don't do anything. That means this one actually will be omitted automatically. It's an imperative paradigm, and this is actually a nice, let's say, program that shows you how something like that can be implemented. Okay, now a second lecture we were talking about Java. Okay, and then the question is Java an imperative programming language? And the answer is yes. Okay, Python is an imperative programming language, but we will see actually other features of Python that makes actually Python not only an imperative programming language. We will look at that in a few minutes. Now what I will do is I will go to Java, and I will think about actually the same problem that I want actually to solve. Thus I will implement a program, okay, a method. It's a static method. It will return for me an array of integers, it's called filter out or filter even. Okay, and it takes as a list of integers in this case. And now what I will do is the same way of thinking. I will use a for loop that starts from I equal to 0 till I is strictly less than a dot length. Okay, and then I plus plus, and what I will do is I will check actually the following. If a of I is modulus 2 is equal to 0, I know exactly that this one is an even number. And then what I will do is I will go and print, in this case, my a of I and a little bit of space in order that the whole thing actually will look nicer once actually it's displayed. Okay, thus if you take a look at this one, then here you see that the method doesn't return an array of integers, but it's actually a method that doesn't return anything. It's actually a void method, and that's why I will just change it slightly. Okay, I did it on purpose because what we saw in Python was an option, let's say was a way where the result is computed in a list, and then after that I will print actually the result in this case. Okay, now the question is how will I call it? I will go, okay, and I will create an array A, okay, that consists of 1, 2, 3, 4, 5, okay, and last but not least I will call the method filter even, okay, on the list on the array A. Okay, thus in this case, if I will compile, if we didn't do any mistakes, then it will compile correctly. Once you will run it, I want actually to get 2, 4 as a result, and you get actually 2, 4 as a result. Okay, now the question is, what if I want to implement actually something where the list, okay, the method won't actually be a void method, but actually this method will return an array of integers in this case. Okay, I will tell you it's an easy job. Okay, what I have to do is, if I do it actually with the classical way, and I want actually to use an array in this case, I have actually to do the whole thing in 2 different steps. Thus the first step is just actually to count the total number of elements that I'm having that are considered to be even numbers. Okay, and now once we have that, we have it actually already. Thus what I will do is I will just create a new array. Okay, I will call it result. Now I know exactly the size of the array because it is not always actually the same size as the input size. Okay, thus it has something to do with the C, the total number of even numbers. And then what I will do is I will create an array of the size. Okay, now once we have that, we will actually populate the result list, okay, with I equal to 0 till I is strictly less than result dot length, or the C in this case, which is actually the same, result dot length. Okay, and then what I will do is I will just do the test again. I will just compare the following. Okay, here I have to do it for the whole list. Okay, which is the list A. Okay, and then what I will do is I will just check the following. If A of I modulus 2 is equal to 0, what I need to do is I need, let's say, to include my elements in position J. Okay, well, I will tell you exactly what the J is. Okay, A of J is result of J. Okay, result of J is equal to, in this case, A of I. Okay, and what I will do is I will go and increment my J by 1 in this case. Okay, now the question is, the J corresponds to what? The J corresponds actually to the index okay, of my result. That means here I will have actually the following. I will go through the list again from position 0 till I reach a of length, and every time I will do the same thing again. I will check whether a of I modulus 2 is equal to 0, meaning whether my element is an even number. If it is an even number, I will insert it, and after that I will increment actually my j by 1 actually to go to the next one. And last but not least, here at the end of the day, I will return the result in this case. Okay, let me compile. There is one semicolon which is missing, which is the end C. Okay, once we do it, actually this one will look nicer. Now the question is, how will it work? Okay, now I will just create an array. The array is having 1, 2, 3, 4, 5. Okay, this is my array, and then I will just go and create a new, let's say, array result, that where I will store the filter even values of the a in this case. And last but not least, I will have a loop that starts from I equal to 0 to I strictly less than r dot length. Okay, and what I will do is I will be printing the element of the r one by one. Okay, system dot out dot print, and in this case I will print r of I, okay, plus an empty space. Okay, now once I will compile this one, okay, and I will run it. If I have 1, 2, 3, 4, 5, then actually what I am expecting is 2, 4 as a result, and you get actually the 2, 4 as a result. Okay, thus the question is, why is it actually that complicated? Why do I have actually to do this step twice? Okay, I will tell you, this has nothing to do with, let's say, that the programming language Java is not, let's say, the best approach actually to solve it. It's similar to Python. However, the main problem is I decided actually for the wrong tool. Here I'm using an array, and as you know, an array is a static data structure. That means in this case I will not be able to let's say, once the size is fixed, I will not be able actually to change it, and that's why I have let's say, to do it in two different steps. The first step is to count the total number of even numbers in the array, and then next time what I will do is I will create an array which corresponds actually to the result, okay, where the total number of cells corresponds to the total number of elements that are even in the input list, and last but not least I will populate, let's say, this list accordingly. The question is, can I do it differently? And the answer is for sure actually we can do it differently. There is really no need actually to do it with a static data structure, and this is something that you have actually to know, and most probably after taking a look at CSEN401 you will know exactly that actually this problem can be solved in an easier way if you will decide actually to use an array list. Okay, you could have also used a linked list if you think about, let's say, the data structures course that we took last semester. Okay, in this case, instead of using a linked list, I'm using an array list in this case. Now I will be having an array. The array is consisting of 5 elements. Now instead of creating a new array, which is the result list, because in this case I need actually to have its size, I will create a dynamic array. In Java, the array list actually will do that. And then what I will be doing here is I will be using actually a for loop. I will be taking actually the elements of the array one by one, and for, let's say, elements that are even, okay, what I will do is I will add them in my array list, and this one actually your array list will be a dynamic one, and the size of it actually will change. And last but not least, what I will do is, okay, I will actually print it. There are different ways how this can be printed. I'm doing it now with the for loop, okay, that traverses actually the array list till it reaches the last one. That means actually I will be using the size method which is available in the array list, and then every time I will get, let's say, the element in position I of the event list, and then I will print it. Now once I will compile and run it, you will see that actually the result will be the same. In this case I will be getting 2, 4 as a result. Okay, thus look here you are having two different methods Okay, one of them is a little bit more complicated because you have to do the task twice. Thus, the time complexity will remain of n because I will be traversing the array twice. Okay, doing the same job twice. Okay, however, if you will decide about another tool, okay, then your algorithm will be better. And this is exactly the message that I wanted actually to deliver in this case. It has nothing to do with the programming language. It has actually something to do with the tools that you are actually using in this case. Thus, it works. Okay, Java in this case is, let's say, also considered to be an imperative programming language. However, taking a look at CSEN401, we were actually selling Java as an object-oriented programming language because Java has additional features, okay, that makes the programming language an object-oriented programming language, and the features are API, abstraction, polymorphism, inheritance, and encapsulation. Okay, now you go back and you ask actually yourself, what about Python? Is Python having actually these features? And the answer is yes. Okay, Python is considered to be an imperative programming language, but it has also the possibility actually to let's say implement classes. You can use inheritance, encapsulation. You can use, let's say, all features that makes actually a programming language, or let's say this programming language has the features that make actually this programming language an object-oriented programming language. Okay, then we go back actually to our course, and the first programming language that we dealt with was in this case Prolog. Okay, and I want actually to implement this predicate now. Okay, and Prolog is a logic programming language. That means my program will consist of rules. Okay, that's what I want to do is I want to filter, okay, even numbers. Okay, filter even numbers, okay, from a list. If the list is empty, then the result will list is an empty one. Okay, now the way of implementation will be a different one. That means you will be implementing a predicate called filter event. Okay, that takes two parameters. The first parameter corresponds actually to the input list, and the second parameter corresponds to the output list. And filter of even of two lists are L and R holds if and only if. In the R, I am having only the elements of the L that corresponds actually that are in this case even numbers. Now the question is, what will happen if I have a list which is not an empty list? I will be having a head and a tail. Okay, then I will be distinguishing between two cases. The first case is I will be having an head. The head actually will remain, okay, and the tail I have actually to compute it. And when will this be the case? If h modulus 2 is equal to 0. Okay, and what I have to do is I have actually to call the filter even of, in this case, t and t1. This is actually the first case. Okay, thus I'm saying actually the following: if h is an even number, I will keep it. Okay, now I have actually to, let's say, do the following. What if h is not an even number? This is actually my last case. In this case, I will be having a wildcard because I don't care about the h. I will not check it again. Okay, and what I will do is I will get t1 as a result, and the t1 I will get it just by filtering odd numbers from actually the t in this case. Thus I will be calling a predicate filter even recursively, okay, of t and t1 in this case. Okay, now I will go, I will compile, and then I will call filter even, okay, of a list that corresponds to 1, 2, 3, 4, 5, and the list is L, the result list. And then what I will be getting here is I will be getting 1, 2, and then in list, okay, Why is that? If H modulus 2, then I should get only 1, 2 as a result. Filter even of T and T1. Okay, I hope that this one, filter even of an empty list, filter even of HT1. If H modulus 2 is equal to 0, sorry, I will be having here a small problem, which because I am now using the semicolon, I should have used, let's say, the AND. Okay, I will do it, then you will be getting actually 2, 4, which corresponds actually to the result in this case. Okay, I had actually here a problem, since actually we are going from one programming language to another. This could actually happen that even in the exam you will actually get confused. You have actually to take care. I was using actually the semicolon. The semicolon in Prolog corresponds to an OR, and that's why I was getting actually a weird, let's say, result in this case. It should be an AND. Thus, if you want actually to read it, this one actually will be read in a logical way, and that's why the programming paradigm that we are actually dealing with here is the logic programming paradigm, where a program consists of a set of rules, and here the rule says the following: if I am having to filter elements from an empty list, then the result will be an empty list. If I want actually to filter elements from a list which is not empty, I will be just considering the first element. Okay, if the element is an even number, then actually what I will do is I will keep it in the result list, and what I have to do is recursively I have to filter all odd numbers from the T, and then I will be getting T1 as a result, and that's why here I will be concatenating the T1 to the H in this case. And the last case is, okay, if this one is not, let's say, doesn't hold, is not true, then I know exactly that H modulus 2 is not equal to 0, and that's why what I will do is I will skip it from the result list, and I will keep only, in this case, the T1 as a result, which corresponds to filtering all even numbers from the list without the first element of the input, okay, to get actually T1 in this case. Okay, it works. Now you see actually a different way of programming, where here we will be relying purely on recursion. Okay, because the programming language doesn't have actually any loops, and let's say my program doesn't consist of, let's say, statements that we are actually doing. In an imperative programming language, the state is always a set of variables that I will be changing over and over again. This is exactly what I am doing here. Okay, look, I am having a set of variables. If this is actually my variable, which corresponds actually to the input list, okay, and this is my result, which is, let's say, the variable that corresponds actually to the result array that I want actually to compute, you will see that actually every time I will be changing the content of this variable. Okay, and this is, let's say, the main concept of an imperative programming language. The same if you go to Python, you are having actually the same. You start with the result, which is an empty one, and every time, if, let's say, the number is an even number, you will include it in the result. If it is not the case, you don't actually do it, and that's why the whole imperative paradigm is based on statements, on orders, where the orders are done on a set of variables, and the variables, I will be having input variables and output variables, and while you are performing the statements and the orders, the state of the variables could change in this case. This could never be the case in a programming language like Prolog. If I write x is equal to 4, and after that you want to change your mind just to say that x is equal to x plus 1, okay, you have to know exactly that this one will never work. Okay, thus you do not have any side effects in a programming language like Prolog. Okay, let's go actually to the last paradigm, and the last paradigm is the functional programming paradigm. Okay, I won't actually mention C, because actually C looks like Java is a little bit of syntactical sugar in this case. Now the question is, what do I want to implement? I want actually to implement the filter even of a list L. Okay, that's if the list is an empty one, then you get actually an empty one. Okay, and if the list is not an empty one, then it consists of let's say 2 elements, x and xs. Okay, that's what I will do is I will write actually something of the following. If mod x2 equal to 0, what I will do is then I will keep it. Then in this case I will keep x, okay, and I will consist with a filter even of xs. Else what I will do is I will just actually call the filter even of xs in this case, and I will not let's say connect it with, I will not concatenate it with the x in this case. Okay, thus I will go here, I will go and let's say load the comparison one, and then I will check filter even, okay, of a list that consists of 1 2 3 4 5. Okay, and what I will be getting here is I will be getting 2 4 as a result, and it works. It's really nice and it's straightforward, and it's similar, let's say, to the Prolog program, except the syntax is a little bit and the way of thinking is a little bit different, because in logic programming what you can implement is only, let's say, predicates. The values of them is always true and false. Okay, now once you go to a functional programming paradigm, the functional programming paradigm is based on expressions, it's based on functions, and that's why I will be implementing one function that takes as an input a list, and it returns actually for me as a result actually a list. Okay, now let's go back and let's go actually to the programming languages. Okay, and then let's start actually to compare them, let's say one by one. First of all, if you take a look at actually this program, you won't see me implementing anything that is having a data type, and that's why people actually will think Python is not a typed programming language, but this is actually not the case. Python is a typed programming language. If you go to Java, then you see me specifically every time I will be defining a variable. Okay, I will be giving, I will declare it actually first. I will be giving it actually a type. If you go actually to Prolog, I'm using SWI Prolog, and SWI Prolog is not a typed programming language, although I'm using actually here a list, but the list is nothing else than a structure. Okay, that's the programming language. SWI Prolog is not a typed programming language, but there are some of the Prolog implementations that are actually typed in this case. And last but not least, if you go to Haskell, the same thing. Everyone actually will think in Haskell I'm not using any let's say types, as if actually the programming language is not a typed one. However, if you go here and you write :T5, you will see exactly that the programming language is a typed actually programming language. Okay, now if you will go here and you will ask about the type of filter even, okay, you will see exactly that this one actually will be generated automatically from, let's say, the inference engine of the type system of Haskell. It tells me, okay, the list is a list of integrals. Okay, and once I will perform an operation on it, because actually the mode makes actually this one an integral 1. Okay, and it tells you the output will be also of the same input in this, also the same type of the input in this case. Okay, now let's go and let's think about a better way to implement the filter method, okay, or the filter function or the filter predicate in the different programming languages. Okay, now I will start actually with Haskell, because this is, let's say, a programming language where one of the lectures that we gave is about something we call higher order functions. Okay, that the question is, can I implement a filter even numbers? Okay, I will just call it evens. Okay, where I will be using a higher order function which is predefined in, let's say, the programming language that filters even numbers. In this case, I will write evens filter, okay, even. Just actually keep in mind that evens takes as a parameter l, and then this one will take filter. Filter takes two parameters. The first parameter is a function which is a Boolean one. The even is a predefined one. I can actually show you this one. Even, it's a predefined one in the prelude. Even 8 will give me true. Even 9 will give me actually false. In this case, it's a predefined one. And the filter is a predefined function in Haskell, which is a higher order function that takes actually two parameters. The first parameter is a Boolean function, and the second parameter is a list. Okay, now the question is, well, what would happen if I will go and code the events of 1, 2, 3, 4, 5? Okay, and then I think if you get actually the same result as we got actually before, with a more concise one, because this is actually a typical, let's say, problem that can be implemented using higher order functions. Okay, it's nice, it's really good. However, actually you have to know exactly how the filter actually works. And now the question is it possible to implement actually the filter in the different programming languages? In this case, you will see it actually one by one. Okay, now we saw exactly how the filter has been implemented in Haskell, and that's why I will not repeat it. And then I think is, since I am using, let's say, Haskell is a query programming language, and that's why what I will do is, since the L appears to the left and to the right, I can actually remove it, and the whole thing will work actually properly. And once you will do events of 1, 2, 3, 4, 5, you get as a result 2, 4. And once you ask about the type of events, okay, now it's okay, once you ask about the type of events, it tells you, okay, it has something to do with the type of even. In this case, the type of even is takes as an input an integral a, okay, and it returns actually a Boolean 1. Okay, and that's why if you want to ask about, let's say, the type of events, then the whole thing actually will work from a list of integers, okay, to a list of integers. Okay. And here you see that the programming language is a typed 1. Okay, now let's go further. Typed, although I'm not using actually any types here. Okay, however, okay, the way how you are actually using your let's say functions, okay, there is behind the scene, okay, a kind of a type inference engine that will just detect and infer the most general data types that a function actually could take in this case. Okay, now we go actually to Prolog, and we want actually to think about the following. Is it possible to implement a filter predicate in Prolog actually to perform the same task? And I will tell you, yes, this can be done actually easily. Okay, you will just implement a filter predicate that takes actually two parameters. The first parameter actually corresponds to the predicate that you want actually to apply on every element of the list. And then you are having an input list, and then you are having an output list. Now the filter one actually works as follows. Okay, now the first thing is I will take actually the predicate and I will apply it on all elements, meaning in this case I will apply it on T and I will get actually L1. Okay, and last but not least, what I have actually to do is I have to do the following. You check, okay, if applying the predicate on H will be true, then L corresponds actually to the H because it just satisfies actually the condition. If the predicate is even, okay, then in this case what will happen here is that if I have 4 is an even number, and that's why 4 has to appear also in the result list, and then I will have I have already, let's say, implemented my filter recursively, meaning I applied the predicate on all elements except actually the first one. This is actually the tail list. Okay, and if it is not the case, if I will call it, the call is a predefined one. Okay, it makes, let's say, something similar to higher order function. I will be calling the predicate, okay, on age. Now, if calling the predicate on age will not actually give me true, then it will give me false. This is an if then else in Prolog, then actually the L will be L1 in this case. That means I will not include the age in the result list. Okay, now once we have that, okay, implementing events predicate is a straightforward one, because what I have to do is I have actually to take all elements, okay, even of the ES. I will just actually take all elements. This is, let's say, another one where I will not rely on, because actually this one will correspond, if I will call it, let's just actually focus on this one only. Okay, if I will just actually call it, I will call it with filter, and then you have to define the predicate itself. Okay, and then once you have it, events DES corresponds actually to the following, where you will find, let's say, all elements one by one. You take actually the member elements one by one, and you check if E modulus 2 is equal to 0. Then this one actually is true, it will be kept in the result list, otherwise it won't actually be added in this case. Thus, if I will call the events of a list that corresponds to 1, 2, 3, 4, 5, okay, and then the result list L, what you will be getting here is you will be getting actually 2, 4 here. I'm using now the find all, okay, where I will be going through the list one by one, and I will be checking actually my predicate in this case. Now, the filter one is a different one, where I will be calling, let's say, the filter on a predicate in this case, okay, and if the predicate corresponds to, let's say, the modulus or the odd, then actually this one will work. If I have, let's say, something of the following form, okay, odd of x, okay, will give me x mod 2 is equal to 1. Okay, now if I will go here and I will call odd 4, okay, then an odd of 4 will be false. If I will do it with 9, an odd of 9 actually will be true. Thus, the filter could work as follows. I will be giving an odd as an input. A list corresponds to 1, 2, 3, 4, 5. Okay, and I will be having a list L, and then you get as a result 1, 3, 5. Thus, here you are having 3 different ways how the whole thing will be implemented. The first one is let's say a classical one, where you will be filtering actually the elements one by one recursively. Okay, the second one will be, let's say, something that will generalizes the predicate itself. Okay, and in this case I will be defining, okay, a predicate. I will not say with a higher order predicate, but actually as an input you get also a predicate as an input. That means for sure it's also higher order. Okay, I'm relying actually on the call, and now if I want to do it with an even, I will just change it with even x mod 2 equal to 0. Okay, and what will happen in this case, you will be getting the same result. Okay, thus if I will do it with filter instead of odd, I will do it with even, then you will be getting as a result actually 2, 4. And the last actually approach here is just actually to rely on the strength of Prolog, where Prolog is having the backtracking step let's say, integrated in the programming language. Okay, how this one actually will work is an easy one. If I have, let's say, a list, okay, the member of 1 2 3 4 5, okay, and E will be let's say no, I have to do it recursive, E of let's say 1 2 3 4 5. Then actually here you will be having an enumeration that is done automatically for you, because actually Java Prolog is a logic programming language that is based on three concepts. The first concept is unification, the second concept is resolution, and the third concept is backtracking. Thus it tells you if E is equal to 1, then the member of E 1 2 3 4 5 holds. And then you will ask about alternatives. You will be enforcing the backtracking. It tells you, and if E is equal to 2, then the member of E 1 2 3 4 5 holds. And then you get actually everything. And now look, if I will combine this one with the following, E mod 2 is equal to 0, you will see that actually in this case I will be getting only the even numbers, because 1 is a member of the list, but 1 modulus 2 is not equal to 0, and that's why this one will be skipped. Then the backtracking will go to the second element, and it checks actually E equal to 2. Then the third element, E equal to 3. Okay, however 3 modulus 2 is not equal to 0, and that's why you will be getting it E is equal to 2 and E equal to 4. And what I'm doing here is a find all, just actually to be able to get all results and put them in a list. In this case, this is actually the third approach. Thus you see something which looks really nice, neat, and so on. Okay, now let me go back and take a look at Haskell. Okay, now this is let's say a programming language which is a functional actually programming language. I'm relying on, let's say, a filter method or function that is predefined in the programming language in this case, and the even is also actually predefined. Now the question is, what if I don't have the even? Okay, I will do it with is even, and I want actually to implement it. Okay, now if you want actually to implement it, then this one actually can be implemented with, let's say, something called the lambda calculus. Okay, the lambda expression. I will write something of the following form: lambda x, and then I will write mod x2 is equal to 0. Okay, thus this expression is implemented actually with, in this case, a lambda expression. And once I will go here and I will call it is even, okay, is even of 6, okay, will be giving me actually true. Now look, what I am doing here is I'm using already, let's say, the curried actually version. Okay, thus this function is a function that expects as a parameter 1, and that's why I'm writing actually x. And what it does is it just actually checks whether x modulus 2 is equal to 0, and that's why if I will do it with is even n, and then I have to write the n actually on the right. Thus once I will go and load and call it is even of 6, then you get actually the same result. Thus again, like we did actually before, now you will remove actually this one, you will remove actually this one, and what you will do is you will be calling, let's say, the function now evens, okay, on a list that consists of 1 2 3 4 5, and you get actually 1 2 3 4 5. Now I will do a little bit of unfolding. Okay, thus in this case, if I don't want actually to implement actually this method, I can do it actually in the following way. Evens corresponds actually to filtering elements, okay, based on predicate, okay, a function which is a Boolean function that checks whether x modulus 2 is equal to 0. Now once I will do it, the whole thing actually will work and life actually will be good. Thus the evens 1 2 3 4 5 will be giving me actually 2 4 as a result. Okay, now let's go back to the first programming language that we learned here at the German University in Cairo, which is Python. Now what you see here is a program. The style of it is an imperative style, meaning I will start with the list, which is my input. My result list starts actually with an empty list. And what I do is, every time I'm changing the value of the result, depending on whether the E, which is the element in the list, is an even number or not. That means I go and I traverse the whole list from the first one till the last one, and I will check, is this element an even number, yes or no? If it is an even number, I will add it to the result. If it is an odd, I don't. And last but not least, I will print the result. Now, the programming language that we are dealing with here is an imperative programming language. Now, what I will do is, I will remove actually everything, and I will think about the following. Okay, let's just actually check Haskell. Haskell is an imperative programming, is a functional programming language, which is based on a nice concept where everything that you are writing an expression, and if you are having expressions, you can actually build higher order expressions in this case, and this is what we did a few minutes ago. Now, what I will do is, I will go and think about actually the following. I want to implement a function, okay, based on a higher order function. In this case, that's the function is even, okay. First of all, is just actually a function that checks whether the number is even or not. That means I can do it with an if then else statement, but what I can do is I can just express it as, let's say, an expression which is a lambda expression in this case. Thus I will do, and I will write lambda x, okay, and then x modulus 2 equal to 0. Okay, and now once I will run, Haskell will tell you, okay, what you are actually writing is something which is accepted. That means there is the concept of a lambda expression in Python. Now, what I want to do is, I want to implement now, I want to create a new list 2, where the list 2 corresponds to filtering elements of list 1 based on the function is even that we implemented a few minutes ago. That means I will write something of the following form is even, okay, and then list 1. Okay, now once I will run it, Python will tell you, okay, I accepted to. There is a predefined function filter that takes as a parameter another function which is even. It's a higher order function in this case. And last but not least, I will print the list 2. Now, what you will get is something actually weird. You don't get actually the result, but it tells you the filter, according to Python, is something that will return for me an object. And what you have to do is, in order to get a result, you have to typecast it into the corresponding data type. In this case, I know exactly if I want to filter a list, then the result will be a list in this case. And that's why what I will do is I will just use the list function, which is the typecasting one. Thus, the filter will return for me an object. The list of this object will return for me this list, and then once I will run it, you get actually 2, 4 as a result. Thus, if you will think about, let's say, what we did so far, let's say with Haskell, it's almost actually the same. Okay, thus you are having a function, okay, evens, okay, that uses actually the filter, and it is applied on let's say a lambda expression. In this case, if I go to Python, then the way of writing it actually is a similar one. Now the question is it possible to take actually this one and plug it actually here directly? Okay, and this one will be removed. Okay, once you will run it, you get actually the same result, and here you will be having, let's say, the same way of writing it here, where the events as in Haskell will just actually use the filter function, which is a predefined function, and here in this case it takes as a parameter an expression which corresponds actually to a Boolean function, which is written in lambda calculus or in lambda expression. In this case here it's actually the same, and here it shows that Python is a multi-paradigm programming language, and this is actually then I think in this programming language, just dealing actually with this programming language, and that's why it became one of the most used programming languages ever. It has a lot of advantages, and Python is really good because it has a lot of libraries. It has a lot of libraries related actually to machine learning, related to image processing. It's easy actually to learn. There are, let's say, different platforms that you can use the programming language, okay, and it's becoming more and more actually popular in education as well as business use. Now, if you go actually to Java, Java remains also one of the most actually used programming languages. It's actually used a lot. In this case, it's more complicated actually to learn than Python due to the fact that the syntax is a little bit stricter than the syntax of, let's say, the programming language Python in this case. Okay, now the question is, what about Haskell and Prolog? Are they used in the industry? And I will tell you, yes, if you go and you take a look at Haskell in the industry, you will find actually a nice wiki, and you will find a lot of applications that are using Haskell in this case as a programming language. Here you see actually a list. Okay, it's even actually the Deutsche Bank, okay, is using actually the programming language to solve specific actually problems in their enterprise. That means actually this programming language, despite the fact it was actually introduced as an academic, let's say, programming language, mainly actually to solve problems related to sometimes actually AI problems. Okay, it became a programming language where a lot of applications are implemented in this case. Prolog actually remains still actually a programming language, which is a nice one actually for rapid prototyping. However, there are also a lot of applications. The most actually used one is Watson. Watson is a question answering computer system developed actually by IBM, and this Watson is one part of it, not actually everything, is implemented actually using Haskell, actually mainly for pattern matching over natural language parse trees. And that's why you see that actually depending on the nature of the programming languages, there is always a use of them. And that's why, let's say, the aim of the programming or the concepts of programming languages course is just actually to tell you that there are variety of programming languages, there are variety of paradigms depending on the problem that you are actually having. Sometimes, let's say, an object-oriented paradigm is the most appropriate one. Let's think about it. If you think about the game that we are implementing in CSEN401, for sure having actually a better programming language for structuring actually the code will be much better than implementing it in a kind of pure, let's say, imperative programming language without the object-oriented features. Thus, the larger the problem is, the more relations between the classes you have, the better it is actually to use, let's say, Java. However, if you think about, let's say, the programming language C, let's actually go to the advantage of it compared actually to Java, although that is actually a kind of an extension of C to go to C# or C++, that makes C not only an imperative programming language but an object-oriented programming language. In C you are actually having the freedom to allocate and deallocate the memory the way you want, and this will give you an idea or a kind of an edge compared to Java in order to access the system level of your computer, which is not actually possible, or it's really tough actually to do it in Java, because in Java you do not manage your memory yourself. The memory is managed automatically for you, and that's why whenever you want to go to system level programming, C will be most probably the most used and the best programming language that will give you the possibility to access the pointers, just to be able to, let's say, work out your memory the way you want. And that's why once we want actually to classify programming languages, the programming languages are classified not only into, let's say, paradigm, logic programming language, functional programming language, imperative programming language, but they are also classified in terms of high-level programming language, intermediate or medium level programming languages, and low-level programming languages. If you go to low-level programming languages, you are taking CSEN, I think the computer organization course. It's actually a pure, let's say, low-level programming languages, where you are actually dealing with registers and you are shifting and moving actually from one register to another if you are dealing with assembly. If you go to the medium level programming language, C will be considered to be a medium level actually programming language. And if you want actually to go, let's say, to higher order programming languages, then all programming languages that we dealt actually with, which are Haskell, Prolog, Java, are considered to be high level programming languages in this case. Just keep in mind, there are other programming languages that you have to learn, especially you as MET students. Okay, people will expect you to learn actually JavaScript. JavaScript is one of the most used programming languages, okay, just to be able to create interactive effects into web browsers. Please actually keep in mind that if you want actually to work in a company like Google, Wikipedia, YouTube, Facebook, or Amazon, okay, that their front end websites is actually using JavaScript. Swift is another actually programming language. C#, okay, if you know Java, then actually learning C# will be easy, since actually you learn Java as well as C. Okay, C# combines, let's say, the features of an object-oriented features with, in this case, let's say, the way how C actually deals with pointers, which is actually different than actually how Java deals with references in this case. I hope you enjoyed the course. I hope this gave you a kind of a broad idea about the different paradigms and when to use what. Thus, again, I do not want you to be, let's say, a kind of a close-minded programmer who deals only with one single programming language and thinks that actually this programming language is always actually the best, independent of the problem. The main object of the course is to confront you with different paradigms and just actually to deliver the message that depending on your problem, then you have actually to think about using one of the programming languages, one of the paradigms that you learned. Thank you very much for listening. I hope the lectures, although they were given in a virtual way, not face-to-face, were beneficial enough. Hope you stay safe, hope you are actually in a good health, and I hope that we will be seeing you soon here at the German University in Cairo for live lectures again. I miss you, and see you soon. Bye bye. Take care.